Hello everyone, I'm Flora and this is my System Software and Compiler Design Lab Expo number 6. So today we're working on assembler. So basically what is an assembler? An assembler is a program that accepts an input, an assembly language as an input, converts it into machine language and object code as output. So assembly language program, there's an assembler which would convert it to the machine language. So in this experiment, I have given an input as SIC or SIXC input using copy, start, load, STA functions. So what my program will do is it will convert and give an object code as the output. Now what I've done is I have read two files. One is an input file which will have all the assembly language, and then an opcode file which will contain the opcode of the language symbols that we have used. Like STA stands for store the value in the accumulator, so that has a opcode value as 23. So what I've done is I have read those files, stored it, and I have read the input file to find if I find something like start. So start symbolizes that the program will start executing from here. So when I encounter a start symbol, then I check for the name of the program, whether the program has specific name, and I will check the starting address of the program. If the program has a starting address, I will save that address in the memory in my variable and key. Next I have seen is I have iterated to find if I have found directly an end symbol. If without finding an start symbol, I have an end symbol, that would result in the error in the database. So basically in this program what I have done is, for in pass 1 I have collected all the variables, stored it in an intermediate file, and in pass 2 I have calculated the object code out of it. So 2hex is the function that I've used to convert the addresses to a hexadecimal value. So as we saw, 2000 will be converted to an hexadecimal value, and this function will keep on going until we encounter an end keyword. So what happens in pass2 as I said, all that we have calculated, the variable address and the displacement value, all of that is converted back to an opcode using the hex string or hexadecimal opcode. So and if we encounter words like reserve word, RESW, RES byte, then the number of such space address gap will be increased for particular keyword, whether it's a reserve word or reserve byte or word. Next what I've done is I have checked if already a label is present. Then I have already checked it in the symbol table. If it's present, I have alerted the user saying already exists. So, and a hash table. Now what is a hash table? A hash table is a data structure which implements an associative array abstract data byte, a structure that can map keys to values. So particular values are stored in particular keys. So that is mapped and stored using hash table. It is very easy for us to store large amount of data rather than going to n-dimensional arrays using hash table. So when we execute this program, so the output that we get, so when we execute this program, it will compile and give us the machine language code. So if you saw, H stands for head. So when we encountered the start keyword, we printed H, stating that it's the start of it, then the program name, and then the starting address of it, and then we have the object code followed by object. This is the length of the program. Then T stands for the text area, and then the opcodes associated with it, and E stands for end of the file. So that will say that that's the end of the program and the address of the end. So this is all for my assembler program. Thank you.